right, so make sure that you get those notifications set up on that, and then make sure that you get that you understand how to change a photo to a PDF, because all of the documents that you're going to be uploading, like this reality check, is going to be needed to be done that way. And if you have questions on that, if you're like, I've tried, Becky, and I just am not, getting it, just reach out to me individually and I can help you with that. Okay, I am here to help you, and I want to help you in any way I can. And these things that I'm having you set up will help you in other classes too. It's not just for my class, but you'll find that you'll need those for the other classes as well that you might be taking. Okay? All right, let me put this. Or any questions? I should ask, is there any more questions on this reality check number 4 and how we set up those equations? It's usually the solving of them is easier than the actual setting them up for most students. Nada? Buddy got this? Let's see, Ben, your hand's up, but I think that was from before. Or did you have a question on this? Nope, okay. All right, well, let me put this over here, and then I want to let's see. Well, Jordan, you asked about average of scores for the test. Is that making sense to you now, what I mean by what we're going to do? Okay. All right. So I wanted to talk a little bit today. I just wanted to make sure that, first of all, if there's any questions that you have on Module 4 that I can answer for you before you're going to go in and do your test, or your quiz, but it's going to go towards your exam number 2. So I know that last time we met in class, there were quite a few people that hadn't tried the 4.4 homework yet. And so I just wanted to make sure that, if there's questions that you have on any of Module 4, but I guess specifically 4.4, because a lot of people hadn't tried that yet, go ahead and raise your hand now so we can talk about some of those questions. Okay, Angel. Let's see, Angel, did you have a question? Okay. Okay, yeah, I know which kind you're talking about. So let me, I'll write this one in here. So let's see. So if we have a boat going, let's see, upstream at 5 miles per hour. Oops, miles per hour. Okay, and then the return going downstream. So when they go downstream, they're going 7 miles per hour. Right, and then that's all it gives you. And so some students look at that and go, that's not enough information to do this. But let's try and set up our little chart so we can see. So we know we're given some information about upstream, and we know that we're given some information about downstream. All right, and then, oops, we're going to be using that formula of distance equals rate times time, because it's giving us these different things. Okay, and so let's talk about this upstream. All right, so all we know is that it's going 5 miles per hour. So if you're thinking about this, do you see how it's really saying you're going 5 miles in how many hours? So if it says 5 miles per hour, that's saying 5 miles, yeah, in 1 hour. All right, so it's kind of hidden a little bit here that it's saying 5 miles in 1 hour. So our upstream, our distance would be 5, and then our time is going to be 1. Do you see that? And then what about for the downstream then? What would our distance be? And then our time? 1 again, right? 7 miles in 1 hour. And then this part, though, with the rate is sometimes where a lot of people get confused. So let me just say this again. Remember, the rate is going to be, it's comprised of 2 things, the speed of the boat plus or minus the speed of the current. Okay? And so that's important to realize, because sometimes students just put in R here and are like, I don't have 2 variables. And that's because our 2 variables are coming from what rate is made up of. So I always encourage you to make sure that you're assigning your variables, when you're looking at this. So in the very last sentence of this, it just says, find the speed of the boat and the speed of the current in still water. And that just means, or find the speed of the boat in still water. So that's like, if the boat, wasn't going up or downstream, what would it be? What would the speed of it be? And so on this one, I'm just going to call B my boat speed. And I'm going to use C as my variable for my current speed, right? Speed of the current. Not current meaning at this moment, right? But the speed of the current. So how would I write that? So I have these variables. How would I write the rate then for the upstream? Somebody tell me what you're thinking there. Okay, so with upstream, let's think about it. If you're going upstream, are you going to be adding the boat speed with the current speed? Or would you be subtracting it? So if you're going upstream, that means you're going against the current. Yeah, so that one needs to be the subtract one. Okay, so the boat speed minus the current speed. We're going downstream, right? That current's pushing you faster. And so that's why that one's going to be adding it. So if you're just kind of thinking about if you were on a river, right, going downstream, that current's making you go faster. Upstream, it's slowing you down. Yep, and then our equations on this, right, are going to just be 5 equals, well, 1 times b minus c is just going to be my b minus c. And then my other equation will be 7 equals b plus c. And then I think from there, you'd be able to set that up. But usually it's just that remembering, okay, miles per hour, that's meaning miles per 1 hour, and that the rate is comprised of the boat speed and the current speed. Does that help? And do you see how this would be the same if it was a plane question? Right, if you have an airplane, it would be the speed of the plane and then the wind speed, right? The same kind of things are happening. If you're, going with the wind, right, it's pushing you faster. And if you're going against the wind, right, it's slowing that plane down. So, and I'd say probably the mistakes that I see most often on the test for this, so it might happen on your quiz, is people get confused which one needs to be like the b minus c and which one's the b plus c. So just watch that really closely, and it might not even be that they're confused about it, they just write it in the wrong place, and then that causes them to miss it. Okay? Good question. That was a really good one to look at, because that does get tricky to find all that information. Okay. Any others off of there that you want to look at? I mean, you know, more kind of specifics on 4.4. There is a type of problem. We've had kind of those mixture problems, and we had like tickets, cells, or whatever, those kind of problems. Buddy, let's see. Angel, do you want to put your hand down now? I don't see any other hands up for this. And if you want to work on it individually with me too, that is just great. I'm more than happy to do that. And, you know, and usually there's not a lot of people at, you know, my office hours and stuff like that. So please just come and, you know, join me at that time. And if those times don't work for you, please just, you know, message me and we'll find a time. I mean, I'm going to be here at my house, so not going anywhere. So I will be able to find time to help you with this. Okay. So I just need to reach out. All right, let's do a little bit of stuff. I wanted to kind of get in a little bit today. We won't get very far, but that's okay. But I wanted to talk a little bit about Module 5, and we're going to be talking about what's called properties of exponents. And so this is going to be something you're going to see a lot of in math classes. And so it's really important to understand what these properties of exponents are, what these rules of exponents are. So 5.1 is going to be all about these properties of exponents. Okay, and just to review a little bit about exponents, just to make sure it's clear, remember if I have something like 3 to the 4th power, that's really saying 3 times 3 times 3 times 3, right? My base is the number that's being repeated over and over, and my exponent is telling me how many times to multiply those numbers together, okay? So that's what we need to understand about exponents. But a lot of what we're going to be doing is going to be involving some variables. And so this is something that we're going to need to make sure that we understand well if they're not just numerical answers like this, right? And it might tell you to evaluate something like this. I should have said that also. So you can just multiply those together, right? 9 times 9 is 81. So if it asked you to evaluate, that's all you're doing is multiplying those threes together 4 times. All right, but let's get into these properties of exponents and talk a little bit about what they are. So there's going to be 7 properties that we're going to talk about today. Okay, and I'm going to write them kind of in a general form, and then out to the side here, I'm going to give you a little example about them, maybe something that would be similar to what you might see on your homework, okay? But understanding kind of generally what's happening here. So if I have something like this, a to the m power times a to the n power, right? Then I want to talk about this before I fill in the blank here of what's going on. Right, let's look at, see if you can see this one okay. So if I had something like x to the 2nd times x to the 3rd, right? This is saying, write x out twice, right? X times x. And then this one is saying, write it out 3 times, x times x times x. So how many x's are there altogether? Some of you are like, I don't want to respond, it's weird, but I'd like to hear you respond. Okay. All right. Somebody typed in 5. All right. So that's exactly right. So we've got, so this would be x to the 5th power. So if we're thinking of a shortcut way, right, to be able to write this down. So if I have one base to some power and then another base to that same power, what am I really doing with those exponents? Somebody tell us. You can either say it in your microphone or write it in the chat, whatever. Okay, we're adding them, exactly. So when we're writing down the rest of this in general form, we're saying a to the m power plus the n power, right? We added the two powers together, and that's how we got that x to the 5th. Okay. All right, so that's one property. Maybe over here, I'll just kind of put a little example of it. Okay, let's go to the second property. So this time, instead of having something multiplied together, now we're going to have some division. So I have a to the m power divided by a to the n power. All right. Well, again, if we kind of look at an example of this, let's put this over here. If I have x to the 5th power divided by x to the 2nd power, then really if I wrote this out, right, this x to the 5th is 5 x's, so I'm just going to write them out like this. And then on the bottom, I've got 2 of them. And so whenever I have a division like this, if I have the same number on the top as I do the bottom, then I can divide those out, right? So it looks like I can divide out those x's, right? X divided by x is 1, x divided by x is 1. And so then what am I left with? X to the what power? Yeah, x to the 3rd power. Okay, good job. All right, so then if we're thinking about the shortcut on this, right, so what are we doing with those exponents? So if I have a power of 5 on the top, a power of 2 on the bottom, how am I getting to that power of 3? What's happening there? Okay. And yeah, we are subtracting those. So I'm going to write this down as a to the m minus n power. Now, it does matter with subtraction which way you do it. So you always have to do your top exponent minus your bottom exponent. All right, so make sure it's written in this way. Otherwise, you're going to get the wrong answer there. All right, with addition, it doesn't matter if you do, 2 plus 3 or 3 plus 2, you still get the same answer. But with subtraction, it matters. All right, let's look at another property. All right, so for our third property, we have a to the m power, and then it's going to be inside parentheses, so this whole thing is being raised to an n power. All right, so again, if I had kind of a little example of this, all right, I might have something like, do this, let's do 4y to the 3rd power, all raised to the 2nd power. Okay. So with this, I can kind of look at this in 2 different ways. Remember, this squared is saying take this whole thing and times it by itself. All right, so if I did that, then I'd have 4y to the 3rd times 4y to the 3rd. Whoops. All right. And so then I could kind of use the properties that I know here. So I'm doing 4 times 4 is 16. And then y to the 3rd times y to the 3rd, that takes me up to this first property that we talked about, where we said we were going to add those exponents together. So that would be y to the 6th. Okay. But there's kind of a shortcut that we can do. So will somebody unmute themselves, because this will be easier to just say than try and write something in the chat. what can we do here? How could we get to this kind of a shortcut way without having to write everything down? Do I have to call on people? So pretty close. Notice that we have to square the 4 and square the y power, right? So do you see that? So since we're going to distribute that power through to everybody. So 4 squared gives me my 16 here, and then y to the 3rd power all raised to the 2nd power. When we have a power raised to a power, that's going to give me, we need to multiply it to get there, right? 3 times 2 gives us that y to the 6th. Okay, so if I was saying this, let's just write it down like this. So we just need to make sure that we are multiplying those exponents. All right, and there's another one, I guess a little bit later, where we'll talk about that if something was out in front. Maybe I did that a little too soon. But so this will be a to the m times n power. So if it's a power raised to a power, like we have here, right, then we're going to multiply those exponents together. Okay. All right, let's go to another property here. So our next property is going to say, well, it's kind of more like what I did here. So let's talk about this one. So if I have a times b all raised to the n power. So when we have more than one thing inside that's connected by multiplication, right, they've got to be connected by multiplication, not like addition or subtraction or something, then we're going to give that power to everybody, like I did in this example here. So this example kind of serves for both of these. So that means I'm going to have a to the n power times b to the n power. All right, and then I can't combine these together anymore because my bases are not the same, right? Notice up here, right, the only reason why I could combine those together is because I had bases were the same. My a base, but here my bases are different. All right, so just like here, we could square that and then square the 4, square the y to the 3rd, and that gives us our answer there. Okay. All right, let me stop right there for a second and see what questions you have on these first 4 properties. Okay, let's keep going. Let's get to the rest of the properties then. So number 5, or these aren't in any specific order. It's not like this one's called number 4 and this one's called number 2 or whatever, but the 5th one that we're going to talk about looks like this. It says a over b all raised to the n power. All right, so remember I said with multiplication, you can distribute those through, okay? And the same thing is true with division. You can distribute that power to everybody. But if it's connected by an add or a plus sign in between there, we can't just distribute it through. Okay, this only works with this multiplication and division. Let's do a little example over here so we can maybe see a little bit better. So if I have, let's say we have 2x over y to the 3rd, and then this is all going to be raised to the, let's just do it to the 4th power. All right, so this, you've got to give the exponent to everybody, right? And the part that gets missed is people forget to give that to a power of 4. These guys are 2 separate animals, okay? And they're like, you know, that's like, you know, two kids and I give one of you guys, one of the kids a cookie and not the other one, like that's going to cause problems, right? We can't do that. So we got to make sure that we see those as separate, right? I've got to give the 2 a power of 4, the x a power of 4, and, right, the y a power of 4 also. So when I do that, all right, if I'm distributing that through, I'm just going to write it down this way first. So 2 to the 4th power, x to the 4th power, and then over y to the 3rd, all raised to the 4th power. All right, but let's simplify this more. So what's 2 to the 4th power? Come on, guys, I want to hear your voices. I feel like I'm talking to myself. Come on. Look at it again. So it means 2 times 2 times 2 times 2. Yeah, so it's 16. All right. And like I said, like if you just like do that either on your calculator or out to the side, right? 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. All right, and then we got x to the 4th still on the top. Then let's simplify on the bottom. What do we get on the bottom? What's y to the 3rd all raised to the 4th? Okay, I'm saying y to the 12th. Does everybody see that? Because when it's a power raised to a power, you're multiplying those together. So if you were thinking 7, be really careful. That's just if they're connected by multiplication. This is different. There's a parenthesis here. It's a power raised to a power. All right, so make sure you notice those differences. Okay, and then is there anything else I can do? We got x's up on top, y's on the bottom, so since those are different, I can't combine them together like, like the second property there. If it was x's on the top and x's on the bottom, then I could do that. Okay, but these are 2 different bases, so we can't do that. All right, we're almost there. Whew, okay, 6th property, right? Now there's a lot of properties here. Okay. So on this one, we're going to say a to the negative n power. And this one's kind of tricky because when people see that negative, it kind of freaks them out because you're used to seeing negatives out in front of numbers, but maybe not negatives on exponents so much. But let's see if we can kind of look at this a little bit. So if I have I'm just going to do 2 to the negative 3rd power. All right. Now you got to be careful here, right? Because this is kind of weird when people are thinking about it. They're like, how do I take 2 and multiply it together -3 times? And really, like that's going to be, like that just seems really weird. So the way to make this positive is you're going to actually flip it. So when you see a negative exponent like that, you're going to be flipping that base to the bottom. So I'm just putting a 1 underneath it to kind of help you see here that now the 1 is going on the top, and then 2 to the 3rd power is going on the bottom. All right, so whenever you have negative exponents, I always say think of them as like they're unhappy where they're at. They're unhappy upstairs, but if I moved it downstairs, it'd be happy, right? Maybe, like my kids or something, when we finished our basement, my daughter was like, oh, I don't want to be upstairs anymore. I want to go downstairs, so then she was positive and she was happy. All right, so kind of you can think about it that way. And so our way we'll write this is just 1 over a to the n power. Okay, and similarly, I'm just going to write, this is still kind of part of example 6. So if I had 1 over a to the negative n power, all right, so this time, this child is unhappy in the basement, so where does it want to move? Upstairs, right? So when it moves upstairs, now that power is now positive, right? Happy now. Okay, so just kind of think about that negative exponent is just flipping, right? You're just flipping the fraction. That's all it's doing. Okay. All right. Elizabeth, did you have a question? We can't hear you. Let's see. There you go. I can hear you now. Yeah, so we would want to take that one step further. If we could simplify this more, we definitely want to. Thank you for bringing that up. Yeah. Nope, we definitely want to take that further if you can. If it was a, you know, an x or an x here instead of a 2, then there would be nothing more that you can do. But if your number is a base, always simplify that further. Thank you for clarifying that. All right, one more. We're down to the last property here. Okay, so the last property says a to the 0 power. All right, so anything to the 0 power. So we're trying to think about this. Now, some people have memorized that anything to the 0 power is what? Not 0. Good guess, though. That's what a lot of people think. Anything to the 0 power. All right, I'm seeing some people write things in the chat. People are thinking 1. All right, and that's correct, but most students are like, what? How is that even possible? That just seems weird. How could anything to the 0 power be 1? All right, so that's what we're going to talk about in this little example here to help you see that. So let's say that I started off with something like x to the 5th power over x to the 5th power. All right, and if I wrote this out, right, the long way, putting 5 x's on the top and 5 x's on the bottom, all right, then all of my x's are going to divide out, right? And remember, when I'm dividing these out, I'm making 1. So now this says 1 times 1 times 1 times 1 times 1, which equals 1. Right? But that still doesn't bring me to this. Right? You're like, well, where does that 0 power come from? Well, let's go back to property number 2. Another way, instead of writing these out like this, is we could have used this shortcut way and said, do the top power minus the bottom power. So if I do that, right, if I'm doing x to the 5 minus 5 power, then that gives me x to the 0 power. But it has to equal out to be 1, because what's happening here is everybody has something that they're going to divide out with. And so that is always going to leave a 1. Because remember, when you're dividing them out, you're not crossing them out, you're making 1s. 1 times 1 times 1 times 1. Okay. What can I clarify there? I know that's kind of a weird, tricky one. Nothing? Some of you might just be saying, I don't know, Becky, that still doesn't make sense to me. I'll just memorize this. Anything to the 0 power is always 1. Right? And that's fine for right now, but I want you to be able to see like why things work. It's not just magic, right? Some people think, oh, it's just magic, it's math, and who knows why it's happening, it just does. Okay, but let me show you just a couple of other examples here, maybe next to this, that might come up in your homework, right? So if you had something like so if I had -3 all raised to the 0 power. Okay, well, we said anything raised to the 0 power is 1, right? So that is going to be 1, not -1. Some people are like, well, where did that negative go? Right? Doesn't matter. It's not there. Anything raised to a 0 power is 1. But what if I have something like this, like negative 3 to the 0 power. All right. Well, if I do negative 3 to the 0 power, that's just 1. But then now I need to times it by a negative 1, right? So let me put a little different color here so we can see. All right, that wasn't there to start off with, but I have to think of this as negative 1 times 1. So then I would get negative 1 for my answer. So you kind of have to watch how it's written, right? Anything raised to the 0 power. There's another one that seems to show up a lot and people get confused about. So let's try this. So what is being raised to the 0 power? Is that whole thing being raised to the 0 power? What do you guys think? Okay, Skylar says just the y. Do you guys agree? And see how y is the only one that has that power. If it had parentheses, right, around that, raised to the 0 power, then we'd raise everything, right, to it. But it's just the y that's being raised to the 0 power. So we still need to do the rest of this. So really this is saying 3 times x squared times 1, right? But then we don't really need that 1 there anymore. So our answer would just be 3x squared. Right? So think about that and how that might be different if it said this. All right? Because this, that whole thing is being raised to the 0 power. So that would just be 1. All right, what questions can I answer there? You seeing kind of how to do that? All right, let's do one little kind of example question here, and then I'm going to have you guys, you'll be doing some of the homework and stuff that kind of deals with this, but let's see. So let's have everybody try this one. So what if you had 4x to the 2nd power over, let's do x to the 3rd, or sorry, y to the 3rd, x to the 3rd, all raised to the 2nd power. So this one has quite a few little steps in it. So everybody try this one. Let me give you a couple minutes, see what you can do with it. Okay, so the cool thing about these type of problems is there's a lot of different ways that you can do them and you'll still get the right answer. So if you started this off differently than distributing that 2 through, maybe you decided to, simplify inside first, then that would be fine. And then you could distribute the power later. But I think most of you probably decided to distribute that power through first. So that would look something like this, right? And then we need to simplify this more. So I can see that I have x's together, so everything, everything is simplified, like it's done. If there's no negative exponents, right, so you only have positive exponents, you'll change every positive exponent, or every negative exponent to a positive, and your x's together, your y's are together, your whole numbers are together, right, they're not in different places. They all need to be together, and then you'll know it's all the way simplified. So for this, right, 4 squared is 16. And then the rest of this kind of stays the same here. Just not going to skip the steps. All right, but now I can see, all right, I want to get these x's together. Okay, and I wanted to show you kind of a faster way that you can do this. So some of you may have started off saying, okay, you did the x to the 4 minus 6 power, which gave you x to the negative 2 power. Right, and then you had to flip it so it was no longer negative to be on the bottom. All right, I'm just talking about just this little part that I circled. All right, so you can take it this way, but one thing that I want to show you is what happens is if you're looking at this, if you ask yourself, where are there more x's? Right, well, there's more x's on the bottom. How many more x's are there? There's 2 more. All right, and look at our answer over here, right? So there's 2 more and they're on the bottom. And so that way, I don't know, less mistakes seem to happen with students when they try it that way rather than going this route and having this negative exponent stuff and then having to flip it. And it just is, might make it easier for you. Okay, so then I'll have 16 on the top. Y to the 6 didn't change, there was nothing to combine with that. But then I also get that x squared on the bottom, right? And then there's nothing more that I can combine together because there's no y's or x's or whole numbers, so that would be my answer. Okay? All right. So I think we're going to stop right there today. I want you to work on the homework for 5.1, and you might be able to go a little bit further and do some stuff on 5.2 also, because we talked about all of these different properties of exponents, but next time we're going to talk about more that are kind of crazy involved. You're using a lot of properties of exponents together, so we'll do a lot of examples to kind of show you how to do those, but a lot of the ones on 5.1 are similar to this and not too crazy there on it. Okay. Make sure also that you do your review for Module 4 and then do the Module 4 quiz. And then the retake, remember it's optional. You don't have to do it, but you can do it if you want to try and improve your score. So that is up to you. Okay. Any questions before we go today? You guys got it? I feel like I'm talking to myself. Next time, I'm expecting more people to respond.
Hey, question for you.
Yes?
What is the exact easiest way to get onto this chat? Because it seems like there was a bunch of different ways.
Yeah. So for some reason, yeah, so there was a problem with the way that I was telling you to get on before. So let's just say, let's just go the way that you came in this time, where you just go to our Canvas page and click that WebEx button on the left sidebar. And it shouldn't ask for any kind of a password or anything like that. I know some students say that it gives them a password. I mean, if it is, you could try and use your, the one that you log into Canvas with, but you might be clicking, yeah, you might be clicking on something else, but going in this way, you shouldn't ever need a password. It will ask for your name sometimes, but that's it. But this way is usually a little bit easier. So let's just try this way again next time, and I'll send out a message to make sure that everybody understands that, because that other way, like I said, there's going to be some little glitches and stuff like that that happen, and we'll just have to kind of roll with it. But just go into our Canvas page, click on the WebEx button, click join, and it should let you right in. Okay, and if you're having any issues with it, try and message me. I tried to answer some of the people that were messaging saying it was, there was some issues, but hopefully you got that. Okay. All right, you guys have a great weekend, and I hope that you guys stay healthy and safe, okay? Take care. Bye. Oh, that was loud. Oh, it's really loud. It's so loud. Wasn't it loud before? Almost. You see how to get off Benjamin? So if you scroll over so at the bottom, again, there's like, if you hover over, there's a red X. Do you see that red X? Like kind of when you were looking for the chat box and the participant box. So you have to take your cursor, on your mouse and stuff, and just hover over the bottom of the screen. Still not seeing that. Okay. Well, I mean, when I exit it, it'll take you out of it for sure. We can practice that next time too, okay?